Welcome. We're so happy that you can join us tonight to this very special program. We're grateful for the Friends of Crestwood Library for sponsoring this program tonight. This program is possible and brought to you in part by funds donated by the late Wynne Camus's family and friends. Wynne was a beloved library patron at the Crestwood Library. She used to come pick up her books and we used to have beautiful chats about everything. And when I look up at the stars at night, I know that she's shining up above us and I feel close to her when I look up at the stars. So it's really beautiful that Friends of Crestwood Library chose to spend some of the funds donated in her name, in her honor, to sponsor this program. So before we start, we have a very special guest here tonight, and that is our Deputy Director of the Yonkers Public Library. And Shauna is here, and I would love for her to say a few words because it's a very special week, this week at the library, National Library Week.
Thank you, Z. Good evening, everyone. As Z said, I'm Shauna Porteous. I'm the Deputy Director of the Yonkers Public Library. And it's just really great to be with everyone tonight. I want to thank Joe Rao for leading us on this exploration of the stars, and to the Friends of the Crestwood Library for hosting and sponsoring programs like this. You know, we really appreciate the support and all the love that you bring to Yonkers Public Library, but particularly to Crestwood. And then as Z noted, this week is National Library Week, and today is actually National Library Workers Day. It's the one day a year that we really get a chance to celebrate all the people who make our libraries come alive. And just thinking about the title of this program, it really feels like our staff, the people who serve the library and the community, are sort of Yonkers shooting stars. And the great news is you don't have just one chance to see them, you get to see them every day. So just want to thank everyone for joining us. Thank you again, Mr. Rao, for this program. I'm very excited, and to the Friend of the Crestwood Library, and to Z for giving us some background on the person whose memory this program is for, because I didn't know them. And so I feel like programs like this are exceptionally special. So with that, I will welcome everyone and turn it over to Mr. Rao.
Well, thank you very much, Shauna, and thank all of you for coming tonight. I'm so very, very pleased. To me, this is almost like Old Home Week because, as many of you may be aware, for 21 years, I was in the Yonkers area on Executive Boulevard at the studios of News 12, which, well, News 12 doesn't broadcast from Executive Boulevard anymore after a change in ownership some years ago, and that's when I made a change and left News 12 begrudgingly, but it feels so great to come back to Yonkers. So many of you were so good to me when I was on TV, and you invited me into your home every night for me to give you the latest forecast. In fact, I have something that proudly adorns my home office where I'm speaking to you right now, and I'm going to hold it up to the camera. This is an award that was presented to me by the Yonkers Chamber of Commerce back in, I believe, 2006, when I was voted by the folks in Yonkers as their best television personality. And it was a great thrill to get this award from Yonkers. And again, I still have it on my wall. I took it down just to show all of you. But again, it's great to speak to all of you in the City of Hills tonight. So, and I'm thankful too that the Crestwood Library, one of three wonderful library branches of the Yonkers area, invited me to talk to you tonight about what I think will be a special event. This event you will not find in very many almanacs mentioned because it's something that well, it's a prediction that I have made, and I am now trying to spread the word to as many people as possible, because it may very well be that come the night of May 30th, actually the wee hours of the morning of May 31st. Now, May 30th is Memorial Day. After midnight into the early hours of Tuesday, the 31st, is when we may very well see a very spectacular display of shooting stars. I wrote last year, and you say to yourself, when we were all in the pandemic, what are we going to do? I mean, like, many of us couldn't go anywhere, we couldn't do anything or whatever. So what I did was I just sat down and I spent a few weeks, actually more than a few weeks, a few months, writing a technical paper about this prospective celestial show. And then I turned that paper into a popular article in one of the local popular glossies in astronomy, which you'll see in a moment. And now here I am talking about it live to all of you. And I'm going to do my best to get away from the technical jargon from the original technical paper and explain this to you in terms that will be understandable to all of you, not just the adults, but also I saw a few youngsters in here too. So with that in mind, I'm going to share my screen. This is a PowerPoint presentation, and I will put my program up on the screen here. Start the slideshow from the beginning, and away we go. Now, I mentioned that this particular paper that I wrote in about the meteor shower was put into a popular magazine. The magazine's name is Sky and Telescope. And if you go to any reputable bookstore or outlet where many magazines are sold, you probably will find Sky and Telescope. It's in the May edition. And this is the front page of the 6-page article that I wrote for them, asking the question, a new meteor shower, maybe, just maybe, a broken comet might produce a surprise display at the end of the month of May. So who do we have to thank for this? Well, we have these two gentlemen. On the left is a gentleman's name is Arno Schwassmann. And on the right, we have Arnold Wachmann. And these two people, on May the 2nd, 1930, 92 years ago, discovered a new comet, Schwassmann-Wachmann. In fact, this was Schwassmann-Wachmann 3. This was the third comet that these two gentlemen discovered together. They would eventually discover 4. The fourth one they would share with another person, an American. But this comet in particular, drew a lot of attention after it was discovered. This is the article that appeared in the New York Times that particular year, right after they made this discovery. And the thing that made this comet special was the fact that after the calculations were made on the orbit of the comet, we found that it was going to come on May 31st, 1930, 5,735,400 miles away from the Earth. Now, I must tell you that most comets usually don't get much closer than, let's say, 40 or 50 or 60 million miles from the Earth when they shine in our sky. Those are, I'm referring to the brighter ones. This was coming within less than 6 billion miles. And whenever we have a comet coming that close, it usually puts on either a spectacular sky show or, at the very least, an interesting sky show. Almost 40 years ago, we had a comet that passed very close to the Earth. In fact, in May of 1983, a comet by the name of Iris-Araki-Alcock, discovered by a space probe and 2 Earthlings, Araki in Japan and Alcock in England, found a comet that was going to come within less than 3 million miles of the Earth. And while this comet was not really a spectacular sight, it did get almost as bright as, well, brighter actually than the North Star, Polaris, and it seemed to zoom across the sky during the course of a few nights. So if you were out and about with binoculars or a small telescope, you could have watched this thing streak across the sky, moving from one constellation to another over a span of 2 or 3 nights. It was a very interesting object to look at. Again, not overly spectacular, but still rather interesting to watch. And then in 1996, we had a comet by the name of Yakutake, which was discovered by a Japanese observer. This comet was passed within 9 million miles of the Earth, but it was bigger and brighter and much more spectacular than Iris-Araki-Alcock. It had a bright head and a long ghostly tail that stretched across about, half the sky. I remember one night with a friend of mine, we traveled up to Dutchess County near a little community called Hopewell Junction, where the skies are really very dark. And we just got out of the minivan, looked up, and looked in awe at this thing. You don't often see a comet so spectacular as this. And it was so bright, in fact, that here's a picture that was taken, for goodness sake, from Midtown Manhattan, from 29th Street and Avenue of the Americas. This photo was taken. The person who took the picture aimed toward the top of the Empire State Building. And look, right next to the Empire State Building, this fuzzy blob, that was the comet. You know, you don't get to see a lot of things from big cities like New York because of all the light pollution, but this comet was certainly bright enough to be seen even from the middle of Midtown Manhattan. And that's why there was a lot of excitement in 1930 when Comet Schwassmann-Wachmann 3, and from here on, I'm not going to call it Schwassmann-Wachmann 3 anymore. That's a real tongue twister of a name. I'm just going to call it SW3. And so when Comet SW3 came very close to the Earth in 1930, everybody got excited. Oh, this is going to be a spectacular sight. Oh, we'll be able to see it streak across the sky. But you know what? It was a big disappointment. This is presumably what SW3 looks like when it's far from the sun, a big chunk of ice and rock. And this one was only about a mile across. Most comets are 5 or 10 miles across. For goodness sake, Hale-Bopp, you remember Hale-Bopp in 1997? That comet was 25 miles across. And meanwhile, SW3 was a piddling little thing, only about a mile or so across. So because it was so small and because it was so intrinsically faint, you needed good binoculars. You needed a telescope to see it, even when it was closest to the Earth. It was not a very spectacular sight. But a comet is a comet, and one that's coming very close to the Earth certainly garnered a lot of attention from observatories all over the world. This picture that you see here is the 40-inch refracting telescope at the Yerkes Observatory out in Wisconsin. Still the biggest refracting telescope. There are two types of telescopes. There are reflectors and there are refractors. This still is the biggest refracting telescope. It was built or designed back in the late 1800s, but still to this day, it is the biggest and is also still in use. One of the people who used it a lot around the time when SW3 passed by was this gentleman. His name is George van Beesbroek. He immigrated to the United States from Belgium, and he was particularly interested in the small bodies of the solar system, the meteoroids, the asteroids, the comets. And so Van Beesbroek, known to his friends as Van B, took a good hard look through that big refracting telescope. You might say he had the biggest telescope on the block. In any case, he took a look and made observations of the comet, took pictures of the comet. You see that legend here, 10, it looks like 10 feet. Actually, this is 10 minutes of arc, and that is indicative of how large the comet looked through the telescope. This actually was more like 20 minutes of arc here. So the comet, a couple of weeks before it made its very close approach to the Earth, appeared about 2/3 the apparent size of the moon. But again, you needed a telescope or good binoculars to see it. And it was interesting to watch, and it came and then it went. The time that the comet takes to go around the sun, this particular comet, is about 5.5 years. But after the comet went back out into space in 1930, it was missing in action for the next 50 or so years. These are the dates, presumably the dates when the comet passed closest to the sun in 1935, 41, 46, 52. All of these dates, the comet rounded the sun, but we never saw it. And part of the reason, as I mentioned, is that it was a very small comet, very faint, hard to pick up. But the other reason was that even though we did our best to calculate an orbit for the comet, that orbit was constantly changing. The comet did reappear, finally was picked up in 1979, then it disappeared again in 1985. So why the reason for the inaccuracy of the orbit? And we can thank this big guy. Those of you who remember Earth science, for example, you would know what planet this is on site. It's the biggest in the solar system. It is the planet Jupiter. This planet is 11 times bigger than the Earth, so big that if we could hollow it out, we could put 1,300 planets the size of our Earth inside of it. Jupiter has a very powerful gravitational force, and there are lots and lots of comets that have ventured too close to Jupiter, and as a result, venturing too close means that Jupiter, with its giant gravitational force, is going to either capture it or pull it to one side. Look at this. This is the orbit of Mars right here. We go Mercury, Venus, Earth, Mars. Then further out is Jupiter with its big gravitational force. And Jupiter has captured as many as 400 comets within the orbits of Mars and Jupiter. All of these comets captured because Jupiter, again, grabbed onto these comets with its gravitational pull and said kind of like, hey, come on over here, and put them in orbits that average anywhere from 5 to 10 or 15 years around the sun. So you see, Comet SW3 is a card-carrying member of what we call Jupiter's family of comets. And so it is constantly having its orbit changed by Jupiter's gravitational field. So between the orbit changing ever so often, and between the fact that the comet in its own right was not a very bright object to begin with, that's why it was missing in action for so many years. In 1990, we got a pretty good look at it as it passed the Earth. In fact, it was probably the best passage by the Earth since 1930. Not quite as close, it was about 30 million miles away, but we did get a good view of it then. And then in 1995, we anticipated that it was going to return again in the fall of that year, September, October. But something very unusual happened in that particular apparition. In September of that year, and this is not a big fence, this is a giant radio telescope that is located at the Paris Observatory in France. They use this to analyze the gases within the comet SW3, and they noticed something very unusual was happening. All of the gases, all of the frozen gases in that comet were suddenly increasing. When a comet gets close to the sun, of course, it begins to warm from the solar heat, and the gases unfreeze, and they begin to what we call sublimate into a gaseous head around that nucleus, and that's part of the reason the comet glows. But we were beginning to notice that various gases were starting to increase much faster than they normally would as compared to other comets and in other times when this comet came close to the sun. In fact, there was one, the hydroxyl radical. The hydroxyl radical, if you remember taking chemistry, you might remember that particular chemical, but that particular chemical was spiking very rapidly. And all of a sudden, the comet started getting bright. Now, the comet in 1995 was so faint, you would need a really big telescope to see it. And it was way out in space, far out in space. Yet the comet was starting to brighten really fast. In fact, over at the Central Bureau for Astronomical Telegrams in Cambridge, Massachusetts, they put out a special circular about Comet SW3, Schwassmann-Wachmann 3. And in particular, they said, the Bureau has received numerous reports from observers worldwide of independent discoveries of this comet, which has continued to show its remarkable outburst in brightness. Now, you want to know how bright this thing got? This thing got so bright in October of 1995 that you were able to see it with your unaided eye. You didn't need binoculars. You wouldn't have needed a big telescope to see it. And this was incredible because the comet in October of 1995 was located at a distance of 122 million miles from the Earth. Now, wait a minute. Hold on for a second. You remember in 1930 when the comet came real close to the Earth, less than 6 million miles away? And still you needed binoculars. Still you needed a good telescope to see it. Now the comet is 25 times further out into space, but there it is. There it is. It got 400 times brighter than what had been predicted for it. What the heck is going on? And many observers who stepped outside, I can only imagine, some of the assiduous or enthusiastic sky gazers who, go out on a nightly basis with their binoculars or a telescope, can you imagine stepping outside, looking up at the sky and seeing this fuzzy patch of light and say, what is that? What is it? And you look at it with a binoculars or a telescope. Oh my goodness. Oh my goodness. It's a comet. A comet. And you run over and you send an email to the Central Bureau of Astronomical Television. I discovered a comet. I discovered it. It's mine. I saw it. It's out there. And you give the positions and you jump up and down. You get all, and then the Bureau gets back to you and says, sorry, it's not a new comet. It's an old comet. It's Schwassmann-Wachmann 3. Schwassmann-Wachmann 3, that's usually a little piddling little thing. One of the observers who saw it was a very well-known comet observer and somebody who actually has discovered a few comets on his own, Terry Lovejoy in Australia. And Terry Lovejoy wrote, it looked like a mini Halley, a miniature Halley's comet. The coma, the large gaseous head of the comet, displayed a striking parabolic outline. In other words, it was kind of like an oval or elliptical shape, and the tail was so intense in its first half degree that the ghostly glow was evident even through horizon haze. In other words, when the comet was down low near the horizon, where it's rather hazy, you still could see it quite easily, even through the haze. What happened? Why did the comet do this? Why in 1995, all of a sudden, did this comet suddenly become brighter than it ever had been? And in the weeks that followed, we got the answer. People watching in their telescopes, observatories, watching the comet, saw that the head started to become kind of bloated. And soon it looked like there were, 2 or 3 condensations in it. And then suddenly in early December, boom, not 1, not 2, but 4 nuclei. The comet had broken into 4 separate parts. And when the comet broke into 4 separate parts, there must have been a tremendous expulsion of dust. Dust, that's what makes a comet bright, because dust can, these little tiny particles can do a very good job in reflecting the light of the sun. So if you got a lot of dust out there, all of a sudden, the comet suddenly gets very bright. And that's what happened with this comet. The comet broke into several parts, and all of that dust came flying out from inside of the comet and made the comet much brighter than it had ever been. Now, the comet came back in 2001, and you see that still with special instruments, you can still see several different condensations or several nuclei associated with it. But in 2006, the comet came very, very close to the Earth. Actually, I should say comets, because there was now no longer one, there was now at least several. But in 2006, the comets, what was left of SW3, was going to pass within like 7 million miles of the Earth. And this time, in 2006, we didn't have telescopes just here on the ground. We had telescopes to scrutinize the comet out in space. 2 giant observatory-type telescopes to look at all of this debris. The most famous and most interesting of all is the Hubble Space Telescope, still in orbit. It was put in orbit back in 1990 and still orbiting the planet Earth and still giving us spectacular pictures. Well, we turned the Hubble Space Telescope toward the various fragments of this comet. By now, more than just a few, and we labeled them in alphabetical order. And we looked at one of the fragments, fragment B, one of the larger fragments with the Hubble Space Telescope. And looky at this. One fragment, no, not one fragment. There are many fragments. Each fragment is breaking up on its own. I don't know, I can count by going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, each fragment, each larger fragment was disintegrating or breaking up on its own. And then after the Hubble was done with it, we had the Spitzer Space Telescope, which looked at it with infrared filtration. And you could see here's one of the larger pieces, then another piece, and then 3 and 4, 5 and 6, 7, 8, 9, 10, blah, 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 blah. There were, in fact, at the last count in 2006, something like 60 pieces. The comet was literally breaking up each time it went around the sun. It was breaking up more and more and more. All of these fragments now out in space. What was once one comet is now many, many, many comets. you could see, look at the orbit of the comet now. The comet, as I said, takes 5.5 years to make one swing around the sun. When it's way out here near the orbit of Jupiter, remember I said that it sometimes gets close to Jupiter and Jupiter tugs on it and changes its orbit slightly. What's way out here, it's high above the orbital plane of our solar system. But then it comes swinging around, down, and look at this. Look at this. Here's the orbit of the Earth. See, we're going around the sun this way, like that. And look at the orbit of the comet. And it seems like right here, right over here, we seem to almost intersect the comet in our respective orbits. We come very close to that comet. So close, in fact, that there were more than a few people who brought up the question, is it possible that maybe we might get a meteor shower out of this comet? Well, this would not be the first time this happened. In the 1800s, 1843 to be exact, there was a comet by the name of Biela. And Comet Biela was seen to break apart like SW3. Now, it didn't break up into 4 pieces like SW3 did. Biela's comet broke into 2. So there were twin comets that traveled around the sun for a while. We saw them in 1846, and we saw them again in 1852. And then we looked for them again in 1858, and we didn't see them. They were missing. What happened? We had a pretty good idea of where they should have been in the sky, but there was no comet, missing in action, just like SW3 was for a half a century. Then the comet was supposed to come back in 1865, and we looked again, and we saw nothing. What happened? Where did it go? And then the big surprise in 1872, the Earth, just like with SW3, the Earth also crossed paths with Comet Biela in 1872. We reached that intersection, that crossing point where the comet should have been. And when we crossed through that area of space and crossed by the path of the comet, and again, we didn't cross paths with the comet was gone. What happened to it? It probably broke up completely. And in 1872, the pulverized remains of Comet Biela interacted with the Earth. And those bits and pieces swept through our atmosphere and produced a spectacular display of shooting stars. It was something that was rather unexpected. Even the most famous of astronomers didn't realize that this was going to happen. There was one in France, his name was Camille Flammarion, and Camille Flammarion traveled from France to the Vatican in 1872. The Vatican, by the way, still has an observatory, and he was there to meet with the director of the Vatican Observatory, Angelo Secchi, and also with the Pope, Pope Pius IX. So when he arrived after his long journey from France, Flammarion said, "I'm very tired. I guess I'm going to go to bed. I'll watch the sun go down." And he did. He enjoyed viewing the beautiful colors. And then he said, "Okay, got a big day tomorrow. I'm going to be meeting with the Vatican Observatory and then later the Pope." And he went to bed. And he missed it. One of the great and most noteworthy astronomers in Europe missed the show of a lifetime, this spectacular display of shooting stars. The next day when he went to the observatory, Angelo Secchi, Father Secchi, told him what had happened. And Flammarion said, "How did you find out about it?" And Father Secchi said, "I would have missed it too. I was in the observatory having my evening meal, and I heard a knock on the door. And I opened the door, and a gentleman I never met came to the door, and I said, 'Yes, what can I do for you?' And the gentleman said, 'Father, could you please explain to me, you being an astronomer, why the stars are falling?' And Father Secchi said, 'What do you mean?' He said, 'Well, step outside and take a look.' And there were the meteors shooting every which way. And that's how Father Secchi got a chance to see the meteor shower. And the more embarrassing thing for Camille Flammarion is when he met with Pope Pius, the first words out of Pope Pius's mouth was, 'Did you see the shower of Diana?' Diana being the goddess of the skies. The Pope saw it, Father Secchi saw it, but Camille Flammarion, one of the great astronomers of the time in Europe, did not. He was surprised and he always regretted it. Well, I'm hoping that we're not going to be surprised again next month. More on that later. Actually, there was talk that there might be a meteor shower when the comet was first discovered in 1930. In 1930, one astronomer by the name of Shibata in Japan said, "I think there might be a meteor shower accompanying this comet." And he suggested that it might occur in early June. He said that it might come from the constellation of Hercules, the mighty hero in the sky. And sure enough, there came a report shortly after that prediction was made of a meteor shower on June 9th and the 10th, where there were 60 to 70 shooting stars that were visible per hour. But I personally think that there's a question mark about that, because you see, only one person, and there must have been many people all around the world looking for this meteor shower, and only one person saw these meteors. And that one, also in Japan, claimed that not only did he see these meteors, which he said were very faint, but he also said, "I have very sensitive eyes." Oh, sensitive eyes, yeah, but he saw it on the night when the moon was full. And notice, if you will, in this picture, you see that halo around the moon. That indicates there were high clouds in the sky. How do you see faint meteors with a brilliant moon, which normally would block the meteors out, and under conditions where there was a thin cloud cover? You probably wouldn't see anything. And that's exactly what most of the world saw. This one person, though, in Japan claimed that he saw it because he had very sensitive eyes. Well, again, that's a very questionable observation. I really don't think that he saw it. Maybe he was trying to make a name for himself. But again, nobody saw those meteors in 1930, except for this one guy. And in the years that followed, when we look for the meteors from this comet, SW3, we've seen very few. In fact, many years we've seen nothing at all. Comets are cosmic litter bugs. Comets, when they move around the sun, well, today we know them to be made of frozen gases that are heated as they approach the sun and made to glow by the sun's light. And then as the gases warm and expand, pressure from the sun, which we call the solar wind, blows the expanding material and the dusty particles embedded in that giant snowball out into space, producing the comet's beautiful tail. And as the comet moves around the sun, all of that debris, that material, is left behind. Comets are cosmic litter bugs. And periodically during the course of the year, several times or more during the year, the Earth in its orbit around the sun passes across the trail of previous comets and interacts with that material, and that creates the effect of shooting stars. That creates the effect of meteors as they streak through the atmosphere at speeds of 20, 30, 40 miles per second. Now, don't worry about getting hit by one of these particles when you hear about a meteor shower, because you see the particles that we speak of are no bigger than pebbles. Mostly they're the size of sand grains or even smaller dust grains. When they streak through the atmosphere at those high speeds, they blaze up, they burn out, and there's nothing to fear. You need a much, much larger, much bigger object, like a big chunk of stone or metal, to come through the atmosphere and hurtle down and reach the ground as maybe a geologic specimen known as a meteorite. But when you hear about a meteor shower, that's the size the particles are generally. That is what you normally would expect to encounter with a typical meteor shower. Now, in 2005, there were several astronomers, several scientists at the University of Western Ontario in London, Ontario, Canada. Yes, for you younger folks, you may have heard of London, England, but there's also a London in Canada in the province of Ontario. And so these people, and I know a couple of them, I know Paul Weigert, I know Peter Brown, I don't know Helen Shins, but she also is noteworthy in forecasting meteor showers. And then there's this gentleman here. His name is, he doesn't live in Canada, but he lives in France. His name is Jeremy Vauballion. And Jeremy, very important, because he has developed in recent years, 20 years ago, he developed a special computer program. Pardon me while I take a sip of water. He developed a special computer program which is amazing. It takes a comet, a virtual comet, and moves it toward a virtual sun. And then the computer calculations, it's a supercomputer program, calculate how much debris is going to be ejected off of the comet's surface out into space, trailing the comet, and then possibly producing a meteor shower. And so these three people from Ontario got in touch with Mr. Valbalyan, Dr. Valbalyan, and said, could we use your computer and calculate whether or not we are going to see a meteor shower in the near future, maybe in 2022, when the comet is going to be close to the Earth. Dr. Valbalyan said sure, and they worked out they worked up a paper, a technical paper, which they've had published. And in the paper, the bottom line was this: looking at the future, no significant number of meteoroids released during the 1995 splitting of Comet SW3 is expected to encounter the Earth in 2022. Wah, wah, wah. In other words, according to the calculations by Dr. Valbalyan and by his colleagues, Professor Weigert and Professor Brown and Professor Shins, no meteor shower in 2022. They published this paper in 2005. Now, here I am. We're in the midst of the pandemic, and I didn't have much to do during that, as I'm sure many of you did. So when I got a chance to read this paper for myself, I said, well, let me take a look and see what I could find out. I have a computer program on my PC, which does its own calculations of orbital objects such as the planets and asteroids and comets. And so I fed into the computer various orbital elements for Comet SW3, and I created with my own PC, in the room that I'm talking to you right now, I created a program which shows the comet and its trail of debris, the stuff that is trailing behind the comet. And I said, okay, let's take a look. Let's see if that calculation by Dr. Valbalyan is true. So here it is. This is, you see, here's the planet Mercury. Here's the planet Venus. Here's our Earth right here. And this is the orbit of the comet SW3. And right there, you remember the point where the two orbits intersect? So if we're going to get a meteor shower, we're going to need to have the Earth arrive at the same time that a trail of debris from the comet is also in this area. So let's start up the program. There, the planets are moving around the sun. Here comes the Earth around in its orbit. This intersection point is about the 31st of May. Here we are, May 31st, 2022. But do you see a comet? Do you see a trail of debris? I don't. Well, I guess Dr. Valbalyan was right. The Earth moves away on its way. And look, here comes the comet, and here comes that trail of debris behind it. But you see, this trail and the comet come later on in the summertime, in August and September. And so that trail of debris comes on by long after the Earth was there. We didn't have anything to intersect or interact with. And so that's why the prediction is no meteor shower in 2022. But after I did this calculation on my own computer, I got to thinking, you know, this is not a normal case. This is a comet that broke up into several pieces. And when the pieces break up, when the comet broke up, it must have flung all of those materials that were inside of the comet out in all different directions, and did it in very large fashion. And also those pieces, those particles, were flung out into space at relatively high speeds. That is a very, very important thing to consider here. I said, this is not like your typical meteor shower that is produced by a comet. You see, when we have a meteor shower, as I said, the particles, small, tiny particles, are ejected off the comet, they go out into space, and they end up trailing behind the comet. And we ultimately will intersect that trail. when circumstances are favorable. But what I am saying here is this is not a normal case of a comet going around the sun and just gently releasing this material out into space behind it. This was a full-flung boom of a breakup of the comet, and pieces and particles and dust flung out in all directions at high speed. And I'm not talking about little pieces of dust or fine sand. I'm talking about much larger particles. I'm talking about big pebbles, or maybe even larger, nugget-sized pieces that have been pushed out into space. And that's an important thing to note, because you see, when you consider calculations of a meteor shower, you consider a number of different things, how the nucleus of the comet, for example, is spinning or rotating, and how the rays of the sun are hitting the comet, and how the material on the comet itself, the volatile material, is jetting out into space in various directions, pushing the comet here and pushing the comet there. And what I'm saying here is that when we have big pieces, large pieces, those pieces are not going to necessarily all end up behind the comet. As I said before, the sun has pressure. Sunlight has pressure. Now, the idea that light has push or pressure might sound strange to you. Now, if you hold your hand up near an electric light, or if you hold it out in the sunlight, you can't feel light pressing on it, but nevertheless, light does have pressure. It's only noticeable when the light becomes extremely strong, as it is near the sun, and only affects very small particles, like molecules of gas, or dust, or sand grains. This is called solar radiation pressure. Now, small particles are pushed away more rapidly by solar radiation pressure, regardless of the direction that they leave the nucleus. And this pressure of sunlight helps to force such dust particles to a position trailing behind the comet. But do you remember I showed you that picture just a few moments ago of those big pieces, those pebble-sized and nugget-sized pieces? That's not dust. That's not sand grains. Those are much larger particles. And particles larger than grains of sand are greatly unaffected by solar radiation pressure. So, as a result, if that be the case, we would have particles not just behind the comet, as we just saw, we would have particles in front of the comet as well. And that is what I was stressing here in a write-up, a paper that I was working on to be published. And if we look here, now watch, here we go again. Here comes the Earth, but now we're assuming that the particles are ahead of the comet. Here's the comet and its particles, and look at that. Look at that. We now indeed interact. In fact, we're interacting between particle 12 and particle 13. This segment right here, and we interacted with it on the 28th of May. And after that happened, I said, oh, well, this is interesting. So now why don't I focus on that one segment of the trail of particles and see what will happen. So I did. I recalculated, I did a number of calculations, recalculated the orbit for those particles that were in that one segment. Again, that comet trail is spread out over tens of millions of miles, both forward of the comet and also another trail that heads behind it. But now we're going to focus on one particular segment, that segment that we apparently come very close to at that intersection point. So now all of those comets, there were 20 of them, 20 particles that I had calculated and worked up in my simulation. Watch what happens. Here's the Earth. Here we are right here. Here again is that intersection point at the 31st or the 30th of May or thereabouts. Now watch carefully. Watch what happens to the Earth. Again, keep your eye on the Earth over here. We're going to have that one segment of material moving along the comet path. Again, made up of 20 different particles. There they are. Watch, watch, watch. Here it comes. Here we go. We're going to come into play, and we are passing through or intersecting with 5 out of those 20 particles. And each particle out of the, I mean, we don't do 20 particles, each particle in its own right representing many hundreds and thousands and maybe even millions of pieces out in space. And the time frame that I got for that was almost May 30th, plus or minus 1.5 days. Well, I published a paper. This paper was published in in a very reputable journal, I might add, the Journal of the Royal Astronomical Society of Canada. As you could see, it was bilingual. Research, articles did research. And what I said in this paper was maybe just maybe, instead of assuming that the particles are behind the comet, they are perhaps also in front of the comet, in which case we would actually intercept those comets, those particles from the comet at the end of May of this year, producing an outburst of meteors. And there were two other papers that were written, one in Germany by a group of German astronomers, Hartwig Luthern, Rainier Orlt, and Michael Jaeger. And there was another paper that was published by Japanese observers, Shon Hori, Jonichi Watanabe, and Mikao Sato. And these people, I am way out of their league. I mean, these people specialize in these kind of calculations, and they have supercomputers. Look at it, my little computer here in my office, my PC, cannot compare to the computer output that these two teams of independent observers, independent astronomers have. And they worked on this on their own, and they came up with their own time. And I would trust their time more than mine. Mine said approximately May 29, give or take some hours. They came up with May 31st. This translates to Eastern Daylight Time, 12:57 a.m. Eastern Daylight Time. So if there's going to be a meteor shower this year in May, that is the date and that is the time to look for shooting stars, 12:57 a.m. EDT, Eastern Daylight Time. So if there's anything that's going to happen, it's going to happen within probably an hour or two of that particular time. But the one thing that really made me happy was what happened a few months ago. Here you see, this is Dr. Valbalyan. Remember, he and several of the Canadian astronomers back in 2005 worked up a paper and said, no meteor shower in 2022, based upon Dr. Valbalyan's very special computer simulations. Well, now Dr. Valbalyan got hold of my paper, looked at it, thought about it for a while, then went back to his simulator and made a few changes and did his own, did a kind of a smaller study on his own and published it. And he wrote, in 2021, Joe Rao, me, published a study showing that if the meteoroids are ejected at higher velocity, they will definitely cause a meteor outburst. Rao also explored the influence of the change of the comet's orbital elements. In this short study, again, he had reintroduced new calculations and published his own new study on this problem. In this short study, we confirm Joe Rao's findings and go slightly further, exploring the conditions that make a shower possible, as well as the observation optimization. So in other words, yes, it's very possible we'll see shooting stars that night, May 30th into the morning of the 31st. And the calculations that Mr. Rao came up with, they seem to be just fine. Merci beaucoup, Professor or Dr. Valbalyan. Thank you so much. It warmed the cockles of my heart to see a first-class, reputable scientist in the study of meteor showers agree with something that I came up with my little computer PC here in this in my office here in Putnam Valley. So we all agree now that when the comet fragmented back in 1995, all sorts of particles went out in all different directions, and that included forward of the comet's movement. So now the question is, how many? how many meteors might we see on that night? Well, a few years ago, back in 2017, the year 2017, people who were out and about on that particular night were actually surprised. They saw a few meteors from that comet SW3, and the calculations showed that those meteors were associated with material that came off of the comet back in 1941. That was when the comet was intact, and that was also when the comet was not really developing much in the way of dust to produce meteors. We came within, in 2017, 102,000 miles of that debris field shed by the comet in 1941. We didn't even get into the good area, the sweet spot, if you will, where most of the material was. We were outside of that when we came by that zone in 1941, but we still saw 5 meteors an hour in the year 2017. Well, now this year in 2022, take a look at this. Now we're going to go through the sweet spot. We're going to go right through, or pass through, the area where a lot of the debris happens to be shed from 1995. In fact, we're going to be coming within about 35,000 miles, the center of this debris field. That's about 3 times closer than where we were when we passed the 1941 area of debris. Now, here's the thing. In 2017, when we passed within about 100,000 miles of the 1941 particles, the debris that produced those shooting stars in 2017, we saw 5 meteors an hour. At this distance, 35,000 miles, we should see, if we do it on a proportional scale, 14 meteors per hour. That would be it, right? Proportionally compared to what we had in 2017, that's what we should see in 2022. We're 3 times closer to the center of the debris field, so that's what we should see, right? Well, not necessarily. In 1941, the comet was one singular comet, and again, it wasn't producing very much in the way of dust, and so we didn't see very much in the way of meteors. But now remember, in 1995, this comet broke up into 4 parts and shed a whole lot of material of all sizes out into space. And so the concentration of material here in this zone, which we're going to pass through at the end of this month of May, the concentration of material must be far greater than what we interacted with in 2017 when we were passing the 1941 meteor field. Far more. How much more? How much more meteor or meteoroid activity would be in this zone compared to what we encountered in 2017? Well, why don't we say 10 times? If it's 10 times more than what we saw in 2017, that means we multiply 14 by 10, and we end up with 140 meteors per hour. 140 per hour. Would you like to see that? 140 shooting stars? That means you'd be seeing meteors shoot across the sky at the rate of 2 per minute. That's pretty good. I don't know how many of you have ever seen a shooting star. Maybe you've seen a few in your lifetime. In that 1 hour, you'd probably see more shooting stars than you've seen in your entire life, unless you've watched meteors most of your life, or looked for meteors most of your life. So that would be a pretty good display, wouldn't it? So why am I bringing this guy up suddenly? I'm sure many of you have seen him. You probably know who he is. His name is Bob Ross, and he has a TV show called The Joy of Painting. Now, very sadly, Mr. Ross died back many years ago. I think it was in 1995. But you could still see him on television, on public television, and you can even watch him on YouTube. Why do I bring Bob Ross into this conversation? Because sometimes when you're watching him create a masterpiece, he does a painting in 30 minutes or less. He's amazing. He does all kinds of nature scenes. And when he gets to about halfway or 3/4 of the way done, he'll look at you with that sly little smile. And he'll say, "Let's get crazy." And right after he says, "Let's get crazy," he starts filling his masterpiece with trees or mountains or crashing waves or whatever. Let's get crazy. I love that, because now I'm going to ask you, let's get crazy. We said a few moments ago, 10 times the amount that we saw in 2017, 140 per hour. But what if the concentration is more than 10 times greater than what we saw in 2017? What if the concentration was 100 times more? Well, if it was 100 times more, 100 times 14, that comes out to be 1,400 meteors an hour. We'd be talking about meteors coming at the rate of 15, 20 per minute. That would be, by the standards of definition, a true, not a meteor shower, but a meteor storm. A storm of meteors. Is that possible? We can't take it off the table. It certainly seems like that is possible. We're certainly confident that there's going to be some amount of material out there that we're going to interact with on the night of May 31st, the early morning of May 31st, I should say. And if it works out that it is 100 times greater, we're going to see quite a show in that late night hour of May 30th into the morning of the 31st. Now, there are a couple of things that I should point out here. Here's the Earth, and pretend that it's moving in its orbit from left to right. We're moving in our orbit at a speed of about 18 miles a second. During November, we have a meteor shower that comes every year called the Leonid Meteors. They are moving almost in the exact opposite direction that the Earth is in our orbit. In other words, when the Leonids come in November, the meteors hit the Earth head on, and they hit our atmosphere at a speed of 72 kilometers a second. That's like 45 miles per second. Tremendously fast. And because they're moving so very fast, they appear very bright. My goodness, even a tiny particle moving at 72 kilometers a second is going to create a dynamic streak of light in the sky, very bright and readily seen. But now here's the drawback to our upcoming meteor shower caused by the SW3 comet. Look at this. The meteors from this comet, this shower, is moving in the same direction as the Earth. So only the meteors, only the particles that are fast enough to catch up with the Earth will be able to penetrate our atmosphere and create a streak of light in the sky. And they're moving only at 16 kilometers per second. So they are moving very, very, very slow. And because of that, that slow movement, that means that the meteors are not going to be probably necessarily bright. They may be rather dim, rather faint. When we had that meteor shower in 1872, the one that Flammarion missed, the one that surprised everybody in 1872 from the breakup of Comet Biela, people looking at the meteor shower described most of the meteors as slow, faint, and evanescent. Remember, this is the 19th century. How many times do we use that word? Evanescent. I even had to look it up in the dictionary. Evanescent, transitory, fleeting, vanishing. So there you go. It looks like a lot of these meteors may be very faint if they are visible at all. But also, with this same shower back in 1872, some exceeded first magnitude. In other words, some of the meteors appeared as bright as the brightest stars, often appearing red with trains of orange sparks. Could that possibly be what we'll see at the end of May of this year? Well, one gentleman at Bootland Farm, Ontario, several years ago, when he was looking skyward around the same time that the this meteor shower was occurring, his name is Pierre Martin. He wrote later on, he said, I saw a single gorgeous Tau Herculid. Remember, the meteors coming from the constellation of Hercules. At least that's what he was looking for when he was watching the sky. I think it was in 2011. He said it was magnitude -1, which meant as bright as the brightest star in the sky, golden yellow, and it left behind a thick wake, or in other words, a thick incandescent trail in its path behind it. So maybe we might just see a few of those. That certainly would be something to look forward to seeing. a bright meteor or a bunch of meteors that look like that in our sky. So where do we look? Typically, with meteors from SW3, we would look toward Hercules. That's why they were called the Tau Herculids. Here's the star Tau in Hercules, and that's where the radiant would be. That's where the meteors would seem to fan out from. But this case, coming up in May of this year, is a special case. This time, it's not going to be Hercules. It's going to be the next constellation over where the meteors are going to be coming from, and that would be in the constellation of Boötes, the herdsman, the bear driver. He is the guy that's running after the big bear in the sky, Ursa Major, with a big stick. And that is the constellation that we'd have to look for on the night of the meteor shower. Now, this here, of course, is our Earth. This is a particular map shows where the emanation point, where the radiation point, where the meteors are going to be coming from and how high in the sky they're going to be. Now, if you are going to be in Baja California, that's in Mexico, on that night, the meteor radiant, the point where the meteors are going to be streaking out from, will be directly overhead. Yeah, you get a crane stiff neck probably if you've been watching like that for an hour. Lay down on a Chase lounge or whatever, and just look up, straight up, and the meteors will be firing out from all different directions above your head. And each concentric circle indicates the amount of altitude in degrees that area of radiation is going to be. So here we are in New York. Here we are in Yonkers. We're halfway between the 60-degree line and the 50-degree line. So the radiant, where the meteors are going to be streaking from, going to be 55 degrees high in the sky. And you ask, well, how high is that, Joe? So make a fist. Hold it out at arm's length. Place the bottom of your fist on the horizon. The top part of your fist is 10 degrees. The width of your fist is equal to 10 degrees. So in this diagram, this young lady here is looking up and using her fist. This would be 10 degrees. This would be 20 degrees. 3 fists, that's 30 degrees, 40 degrees. And then this young man here looking even higher in the sky, looking upwards to 50, maybe 55 degrees, 5.5 fists. And you could do it yourself. I mean, just pretend that you're outside. You go 1, 2, 3, 4, 5.5, way up in the sky. That's where that area is going to be. So we're going to have a good chance of seeing a lot of shooting stars. Here's the sky map. These are the stars. These are the constellations that are going to be in the sky at 1 a.m. Eastern Daylight Time on May 31st, the peak of the shower. Here's the Big Dipper. You've all seen the Big Dipper. Here is the handle of the Big Dipper. And what you do is you stretch a line from the handle. You follow the arc to Arcturus in Boötes. Arcturus is the second brightest star in the sky as seen from the New York area, and also one of the most colorful. It's a yellowish orange star, an amber star, glowing, shining, twinkling beautifully. And it's in the sky at 1 a.m. on May 31st. It will be in the west. So you face the west, face that part of the sky where the sun sets each night. You look up about halfway, more than halfway up, and you'll find that bright, beautiful yellow-orange star Arcturus. And look, there is the radiant. There is the apparent source of where the meteors will be coming from on that night at that hour. Notice how they streak. They'll streak down like this, out, across, and above the Big Dipper, and up and across and over your head, and this way and that way. They all seem to fan out from this apparent source right here in Boötes. So that's where you got to look. More than halfway up in the western sky on May 31st at 1 a.m. toward the star Arcturus in the constellation of Boötes. That's where the meteors will appear to radiate from. Don't concentrate your vision there, though. Just look up at the sky. Keep your eye moving around. Don't look at any one place. Keep looking all over. Pretty soon you should see a streak in the sky. Trace the streak back. And then quickly, you should see another one in the sky. Trace that streak back until you start to notice the pattern of stars. Another one will come by, hopefully intersect in the same place the first two did. And now that is the giveaway. That tells you where the apparent source of the meteors will be. One final note, sometimes like in 1930, when people were looking for that other shower from SW3 Comet, the moon was full and blotted out most of the meteors. In fact, again, only one person saw any shooting stars that night. This time, on May 31st at 1 a.m., no need to worry about the moon. The moon is going to be a very narrow sliver, and it's not even going to be in the sky. It's just past new phase. So the skies will be dark. The skies will be dark. And now one other thing. I know many of you live in Yonkers and come to the Crestwood Library. I would suggest that for this night of the shooting stars, get out of Yonkers, because unfortunately, Yonkers is a very light polluted city. A lot of lights and not many stars. If you're out on, let's say, Neperhan Avenue and looking up, you might see one or two or a few brighter meteors, but you're going to be missing out probably on most of them because of the bright light. So I would suggest on that night, get out of the city and get as far away from the bright lights as you can. Come on up, let's say, to, well, up to some of the state parks in the northern part of Westchester or Putnam, Fonstock State Park, or maybe Ward Pound Ridge State Park. Those are nice dark areas. Maybe do it even better. Go up into the Catskills or the Poconos or the Berkshires. Make a night of it. Up there, the skies are very, very dark, and you could see a lot of stars, and you probably would be able to see a lot of meteors as well. What I'm saying is, the darker you can get your sky, the more shooting stars you'll be able to see. Now, I'm excited about what's going to happen, though I have to admit, I won't be holding my breath because sadly, meteor showers are notoriously fickle. And it's possible that you may get out to a nice dark area, look up at the sky, and you're looking and you're looking and you're waiting, and you might not see anything at all. Still not a bad consolation prize that you've got out of the city and got a chance to, peruse the nighttime heavens and get together with nature, and you're able to see a nice starlit sky. But if we have a meteor shower that night, that's going to be a bonus. There's a possibility also that some of these meteors, most of them could rapidly disintegrate in their flight through our atmosphere. That would further temper expectations. But the fact is that all the calculations that I've done and now others have done suggest that there's going to be something out there that the Earth is going to intercept and intersect that night of May 30th into the morning hours of May 31st. So it seems like it's going to be a good bet for some sort of activity. And if historical patterns are any guide, I must tell you, we're actually long overdue for an event like this. Over the past couple of centuries, it seems that a new, strong meteor shower emerges seemingly from nowhere with some frequency. Particularly noteworthy were the Lyrid meteor shower. That shower comes in April of every year. Nothing to write home about, 5, 10 shooting stars per hour at their peak. But in 1803, for whatever reason, they were so numerous that in Richmond, Virginia, they rang the church bells at 1 a.m. to awaken everybody to come outside and take a look for 2 hours, a fiery display of meteors across the nighttime sky. So many that some people thought the world was coming to an end. And again, let me mention in 1872, the breakup of Comet Biela, just like we had the breakup of SW3. And Biela's comet produced a spectacular shower. And in 1933, another surprise, another meteor shower, this one from another comet, Giacobini-Zinner. This produced what is called the Jacobinids, and some call them the Draconid meteor shower because they seem to radiate out of the 4-star head of the constellation of Draco the Dragon, just above the Big Dipper here. So you see, there are surprise meteor showers that have come over the years, over the last couple of 100 years. They were unexpected. They suddenly appeared, and we have not had a surprise meteor shower pop up in quite a while. Well, maybe this is the shot. Maybe this will be our chance. So now you know about it. you won't be surprised if it does happen, and you won't be watching the inside the eyelid show. In other words, you'll be in bed when this takes place, if it takes place. Again, this could be the shot. I'll be outside watching. Will you? And that is hopefully what we will see on that night in late May of next month, May 31st, 1 o'clock in the morning. Put it on your calendar, and let's hope that we will have a meteor display, a memorable meteor display, a shooting star display on that particular night. And again, I would stress, try and get away from the bright lights of Yonkers and the bright lights of the city. My wife and I, we've already are making plans to travel to whatever dark sky site we can get to, even if it's out in the western part of the United States. If it's cloudy here, we're gone, because again, these events such as this, meteor outbursts and meteor storms, don't happen very often. And I certainly don't want to miss the chance, and I hope none of you get it, will miss it if it does happen as well. So that's